Okay, so this time I have this question path sum. So this is an easy level of question, and given the root of binary tree and integer target sum, return true if the target sum has root to leaf path such that adding up all the values along the path equal to the target sum. So leaf node is a node with no children. Okay, so leaf node is a node which has no children, means its left is also null, its right is also null. Yes. So see 2 and 7, 13, 1. These are our leaf node. And we have to give the path from root to the leaf node. And if that path sum is equals to the target sum given to us. Yes, path sum is what? See, if you see this path 5, 4, 11, and 7. Path sum is 27. Why? 5 plus 4 is 9 and 9 plus 11 is 20 and 11 plus 20 plus 7 is 27. Yes. And if you add this path from top to the leaf node, this will give you a right output 22. Yes. So if you check this, 5 plus 4 is 9, 9 plus 11 is 20, and 20 plus 2 is 22. And target sum was also 22. 5 plus 8 is 13, and 13 plus 13 is 26 again. So this is not our answer. 5 plus 8 is 13, and 8, 13 plus 4, 5, 6 is 17. 17 plus 1 is 18. So again, this is not our answer. So we will get true because there is one path which is giving us right output. So yes, example 2. See this example 2. 1, 2, 3. Okay, and target sum is 5. So you can from top to leaf, if you check that from root to leaf, there's no path here. Root to leaf, there are two paths only here. One is 1 and 2, and second is 1 and 3. If you add both of them, 1 and 3 is 3 plus 1 is 4. So one path is giving me 4 and one path is giving me 3. 2 plus 1. So no one of them is giving me 5. So that's a question. That's a pretty simple question. I will use the recursion here. So let's see. First, I would like to write target sum. Yes, target sum is what? Wait, sum S should be capital of sum. So target sum is 22. Yes, again. So target sum is 22 and output is equals to true. Yes, not view. It's TRU. Yes, true. Yes. So I'll do what? I will use recursion here, bottom up approach. Why? See, I'll calculate a function t. Suppose name is t. I'll calculate it with 1 comma 25 comma 22. Yes, its value, initial value. Initial value root is 5 only initially, and this target sum is 22. Yes. Now I will do what? I will calculate the same. I'll wait. Control Z. Yes, I'm copying this thing. Copy and Control V. Yes, I'll calculate the same function again for these two, but values will be changed. There will be a slight change in the values. Let me show it to you. 4 comma 22 minus previous root, previous value of root. And what is that previous value of root? It's 5. So 22 minus 5. It is what? 17. Yes. So I'm just writing 17 here. 17. Yes. 17. And here also I will calculate it with 8. Its current value, comma. I'll again uh, make this function. I'll again run this function with 8 comma 22 minus 22 minus 5, its previous value. 22 minus 5 is 17 again. So now what will I do? I'll calculate again this same function for this same function with this same function with, let me write it down. So I'll calculate the same function with 11 comma 17 minus its previous value. Previous value was 4. 17 minus 4 is what? 13. 13 plus 4 is 17. Yes. So 13. Yes. And here I'll call the same function with its current value, comma 17 minus its previous value. Its previous value is 8. So I will call it with 9. 9 plus 8 it's 13. 8, 8, 16 and 7. Yes. So 17. Yes. And see 4 plus 4 comma 17 minus its previous value was again 9. Yes. Because what? Wait. 17 minus 8 is 9 only. Yes. So now I will do what? I will again I will do something like this. I'll calculate the same function with, but there will be a change in values. I'll calculate it with its current value, comma. See, I'm decreasing 17, 13 minus its previous value. 13 minus its previous value was 11. So 2. Okay. Here I will run this function with 2 comma 13 minus its previous value, which was 11. Yes. So it's 11. So 13 minus 11 is 2. And here no node. So 13 minus 9. And if I do something like this, 4, uh, let me paste it once. Yes. See, now I'm calculating its current value. I'll use this function with its current value. Wait, uh, can I edit it? Yes. So 1 comma 9 minus its previous value was 4. So 9 minus 4 is 5. Yes, 5 plus 4 9. Yes. So this is our recursion here. See, we have dry run recursion code. So can you guess which is the output here? This is the output. At the output, your value will equal to the target sum. Your value will be equal to target sum. And that if that happens, we are going good. See, if we will return true. Yes, we have that leaf to node path where path sum is equals to the target sum. If suppose no node is equal, see this node is also not equal, this node and target sum are not also equal, and this also not equal. Suppose if this was also not equal, then we will return false. So let me write code for this. Writing code can be slightly trickier for this. So uh, I'll calculate the same function has path sum, has path pa sum. Yes, and I'll calculate it with see, wait. Let left sum is equals to uh, has a path sum. uh, yes, I will calculate it with, see, left is what, 4 comma 17. I'm calculating it with root dot left comma 17. 17 is what, 22 minus 5. 22 minus its previous value. So 22 is target sum minus previous value is what, right now I am at this node. So 22 minus 5 previous, not previous value. I am when I'm, see, when I was teaching it, then I was saying previous value, but right now not previous value. I am at this node and I'm calling this function. So I will call this function with its current dot left. Yes, current dot left is 4. I'll call it this function, call this function with 4 comma 17. 17 is what, 22 minus 5. So current dot well, easy. Yes. So, and that's how I will calculate this also. Root dot right, right, and target sum minus current well, and I'll change this also, right sum. Yes. And suppose if the right not exist, suppose if the if suppose if both the nodes are null. Yes, if both the nodes are null, that means I am at leaf. So if root dot right, root dot right, yes, is null, and uh, null of what, root dot left is null. See, if both node are not existing, then I have to do what? Then I have to just return is my target sum is equals to root dot well. See, at second node target sum was 2 and root dot well was also 2. So yes, they both are equal, I will return. If they both are equal, return true. Yes, else false. Yes, again. And now I just have to return, I have completed it, left sum or right sum. Now you would be confused why I'm writing this. Let me tell you again. So, and if there's again a case, if not of what, root, suppose root is not there, then I'll do what, return false. So let me run this first, then I will explain you. Is there any error I'm making? So let me check. See, current dot val. Okay, root dot val. Sorry, my bad. Root dot val again. So this typo error you can also make. So check it once before running. I didn't check it. Sorry, that was my error. See, and if I submit this, this will be submitted. So now let me tell you why I'm writing this or condition here. So is that submitted or wrong answer? So submission, yes. Okay, submitted. So now if we see why we are doing this, suppose let me make this clean. Let me clean this. Yes. So see, I was doing what? Here I will return true. Yes. And here I will return false. Yes. I will take OR of both of them. Which one is true? It will pass to this function. Now see, it doesn't have any left node. So if it doesn't have any right node, it has left node, but this 4 doesn't have any right node. Yes. So right sum will be called with root dot right, but root dot right is undefined. So whenever I will reach this, I'll return false to root dot right. So suppose this is giving me a false. Suppose just listen to my words. This is giving me a false. Yes, root dot right is giving me a false. And when I'll take OR of them, I will get true here. And this whole node was also, this whole right node was also giving me false. Then I will take OR of both of them and I will return true. Yes, true, false of true and false is, OR of true and false is always true. So that was my solution. This is a slightly trickier solution, I would say. Bottom up approach. There's a top down approach also for this question, and that is quite intuitive today to everyone. But I choose this because this tell you more about more deep about recursion. That's why I choose this to tell you. So that approach is also good. It's easy to write code for that. You have to maintain each level and you have to maintain the sum at each level. That's it in that top down approach. But this is a bottom approach for this question, and this is a good approach. This tell you more about recursion. So thank you so much. That was my solution for this question, and have a nice day. Thank you so much.